Good morning, one and all. I'm Praveen Kumar and I'm currently pursuing BTech third year at Aditya University. So today I want to make a practical demonstration and explanation of my recent project called LLM-Powered prompt router and intent classification. So today we are going to see all the things about my recent project. Okay, first let's discuss about the core requirements and all the thing. Objective. I need to build a Python or Node.js service. Here I have used the Python and web framework I have used is Fast API. Later I will show you all the tech stack and practical demonstration too. So background. What if I told you today's AI production apps won't use a single prompt? They use a intent. They use a classifier that picks the right person, right expert for each question. Don't understand? For example, if when a user gives a prompt, the router classifies into each expert question, expert person. For example, not a person, expert model. For example, if the user prompt is related to the code, it will classify its, I mean, routes to the code intent like that. Yes. Monolithic prompt problem. This is the real world problem. So solution for it is intent based routing. For each response of the each request of the user, it will route to the specific expert intent. They use a collection of specialized prompts, each suited for a different task, a coding assistant, a writing as a coach, and data analyst, and so on. So this process is called prompt routing and is one of the most practical and powerful patterns in the production AI system, real world use cases. For example, Microsoft Copilot. How it works? It will first takes user prompt and classifies into each intent. For example, it may be related to code or writing or data analysis or career advice, so that it will routes the user message plus prompt to the LLM. Your system will implement a two-step process: classify, I told you, to classify each type of intent, and then respond. First, a lightweight, inexpensive LLM call classifies the user intent. Second, the session uses that intent to select a highly specialized prompt and make a second, more detailed LLM call to generate the final response. So if I want to tell you a real world example, so whenever you go to a hospital, you directly don't go to a doctor, don't go and meet a doctor. What we'll do, we'll go to meet the receptionist, and then receptionist will tells you which doctor you need to meet. For example, if you went to relate to the heart, the reception will say go to the cardiologist surgeon name. So like that, here the intent classifier works. So user message. Whenever you type a message in the Copilot related to fix the bug in the code, the classifier LLM. This is the first classifier LLM. So it detects the intent. So we have given to the fix the bug in the code. So it identifies the intent. So what is the intent related to code? So code expert system prompt. I will show the prompts of each system, each intent also. So what if the intent is not clear? For example, here I have used only four: code, data, writing, and career. For example, related to the fitness or health. So it will ask clarifying question. Instead of crashing the system, it will ask the clarifying question. So later then the user query plus first LLM system prompt will be added to the LLM generation call, and final response to the user will be done. Okay, first let me show you the practical demonstration so that you will well understand. Let me check whether the Docker is running or not. So here are some example prompts. Let's test with anything. Can you write me a poem about clouds? So here I have used the text stack fast API. So it's running on the port number 8000. So let me show you the Docker file, Docker compose. Services. I have created one container which name is AI router service. Build dot colon dot means it will create image from the Docker file mentioned at here, and ports 8000 8000. One is the host port and another one is the container port. env file. Why I have used the env file? Because here I have used the Gemini API for the second LLM I have told you. For that purpose I have used the env file and set it secretly. Volumes. The data retrieved will be stored outside of the container in the app. So let's go to this. I have already done this. So let's start fresh. Okay, this is a just a sample message I have added in the main file. So why I have used the fast API is it's better for this AI related applications, and it's an asynchronous web framework for Python, and it's built-in document system for Swagger OpenAI API docs. So I have created an endpoint called chat with post request. Let me try it out. Or you can simply use the curl command to send a post request to the API. What reason can you write a poem about? Okay, we are sending the message. Let's see what the response will be. Yeah, status code 200, which means okay. That sounds like a lovely topic. This is a response generated from the second second LLM call. So first LLM, what it will does, identifies the classifies the intent. For example, here I asked about to write a poem, so the intent will be writing. Confidence is 95%. 0.95 means 95%. It tells us how much whether this response is related to the writing or not. So that LLM, we can also think about how LLM knows percentage. 95% it knows about this concept, so that it's like this. I'll be happy explain for the right graph. So just as an API response, or you can use simply curl command like this. Later we will use that. Okay, coming to the code. First I will show you the prompts.py. Here I have stored the prompts related to the code and data and writing and career. So I have told you that whenever the intent classifier identifies the intent, and then it sends the user message plus the system prompt, I mean these prompts, to the final LLM code. For the intent labeled code, you are a senior software engineer who produces the quality production quality code. Your response must contain a code block followed by a short technical explanation, and avoid conversational chatter and focus only on technical accuracy. For data intent, write like this. For prompt, these are the not extensions, super prompts. Think about like a same super prompts, so that you will get the best responses from the LLMs, and it will have the context awareness. I mean, they have the context. I mean, how to say? It knows more accurate, better than previous. For example, career, you are a pragmatic career advisor. Your advice must be concrete, realistic, and actionable, like that. Let me show you the demo architecture tool. Yeah, this is the architecture. So whenever user sends a message, the intent classifier. Here I have used Gemini Flash API for class intent classification, and then labeling the intent. For example, related to the code, it will be sent to the code expert, and data analyst, and writing coach, and career advisor, so that Gemini will generate the final response and stores in the JSON logging, which means It will be looking like this. JSON, yes, route log JSON. For each response, it will be stored in this JSON single line file. So whenever the response is, I mean, the intent is unclear, it will ask the clarifying question, and if again given, it will be generated as the final response and stored in it. Features about this project: intent-based prompt routing, 4 specialized AI personas. In real world, there will be multiple, but for this project, I have used only 4 structured JSON responses. Here, the objective of this project is to generate only structured JSON response, not about any text response or anything, just only JSON response. Confidence based routing. Manual intent routing means the user can manually override the intent. For example, by defining at the rate of code and explain this bug so that it will identify the intent and makes the work faster. Fast API REST service. Here I have added the endpoint slash post slash chart, which is a post request. And Dockerized deployment, this application is completely Dockerized, and Swagger API documentation, which comes with built-in fast API, and experts personas, code, data, writing, and career. So just now we have seen an example of the writing a poem about clouds. We have already seen this response and confidence and intent. I told you manual intent means we will write at the rate of intent. For example, at the rate code, fix this bug, at the rate writing, improve this paragraph, like that. So logging for every request is stored in the route which contains the intent, confidence, your response, and timestamp also. But for further improvements, I want to use ID also in order to see whether the response is generated for each ID or not. This enables monitoring, debugging, and analytics. Okay, this is the structure of the recent this project: tech stack, Python, Fast API, Google Gemini API, and Docker. Why I have Google Gemini APIs? It's free of cost currently. Future improvements, rate limiting. So what if 10,000 requests will come? Our API will maybe slow down. Gemini API is generally set using 50 requests or maybe per minute. It limits the number of requests and request catching. If the same type of request came, we can catch that request so that it will be time saving and reduce the cost of the API time. And multi-intent detection. For example, in a prompt there will be multiple intents. Like for example, a prompt like how I modify the resume and Python scripts. Here there will be two personas. I mean two intents. One is modify the resume, which means career, and Python scripts related to the code, so that there will be conflict. Background task queue, whenever the services slow down, background task queue like rabbit time queue or like that. Monitoring dashboard. These are the future improvements I want to add. Okay, let me go through the code. I have completed the prompts and this route log JSON. Next, classifier. So what it will does, is load .env, which is used to call the env variable from the .env file. We need to use load .env, and importing the necessary libraries like from Google import generate AI and OS, and from .env, and import JSON. API key I have set in the .env file so that os.get env means from go to the .env file and fetch this Gemini API key and store it in the API key variable. If there is not any API key, raise value error, API key not found. So once the API key is found, we need to connect establish the connection, so that we will use client generate AI.client and API key that are taken from the .env file. So classifier prompt. This is the first API call for the Gemini. I already told you classifies which type of intent the user prompt is. Here an intent classification system, your task is to analyze the user's message and classify it into one of the following intents. For example, I have used four personas, one is code, data, writing and career, one is the unclear. So for this project we need to return only JSON response, not any short-term description or like that. Return only JSON object with this structure. Intent, code or unclear, data, writing or career unclear, confidence, float between 0 0.0 and 1.0. This represents the percentage. For example, if the 0.7 is 75% confident. Do not include any explanation, written only in valid JSON. So this method will classify the intent of the user message. So message will be string format only. So prompt equal to classify prompt, I mean this whole prompt, and user message. Thus you message sent by the user. So here I have used the Gemini 2.5 Flash and prompt equal to the this prompt and content will be stored in the content. Raw text equal to response dot text dot string. For example, at first when I try, it returns the response like JSON and this emmets like this. So that what I did is replaced them with this empty spaces and JSON dot loads cleaned, return the result. I have written that result. I mean the response generated. Otherwise the except exception, the intent is unclear or competence is 0. Okay, classifier done. Next router.py. From prompts.py import the prompts. For example, the code, data, writing or career. For each type of prompt we define in the prompts.py file, and from classifier we are importing the client, and from logger import log root. So here I have used the confidence threshold 0.7. So whenever the confidence is less than 0.7, we need to return intent as unclear, and valid intents are code, data, writing, career. So this is the method route and respond. Intent equal to intent dot get intent. It fetches the intent of the message and confidence from where did in the classifier.py file. So I have told you that we will use the manual override. For example, whenever user types at the rate of code, fix me this bug, it will automatically uses this. The message dot starts with at the rate, parts equal to message dot split, comma 1, override intent equal to parts 0 1. Okay, if the override intent is in the valid intents like code, data or like that, then we store it in the intent variable and confidence set to 1.0. I mean when the user is giving manually and that is in the valid intents, we will set the confidence to 100%. Let me do your own thing. So okay, if confidence is none or confidence is less than confidence threshold, I mean if the confidence is less than 70%, then we set intent as unclear. If intent equal to unclear, what we will do? We will ask the clarifying question. Ask clarifying question, and again final response will be generated. I'm not sure what kind of help you are looking for or you are asking about, so that when the intent is unclear, return the final get intent response dot. So here the final response will be generated, and the final response will be stored in the route log in JSON file. And I have created 4 tests for testing each of the router prompts and classifier intent. So instead of typing, I have set that here. So what it will does, it will this is the test files for this application, which will test the prompts and classifier and router, etc. I have used the PyTest for testing this application. Yes, test session starts. Yes, everything is passed. Let me show them also. So these are the test cases that I need to run, and classifier used to test the classifier, verifies the classify intent output and structure and fallback, and prompts test for prompt.file, verify the structure and content of expert prompts, and router it will be check whether it will be routed to the correct intent I mean or not. Okay, let's test with another example also, which are unclear intent. Let's give like this, can you. So it says unclear. I'm not sure what kind of help you are asking. Are you asking about data analysis or career advice? So that's a thing. Something related to, you use the manual override. For example, at the road code, for example, how to print in Python. So this is an Swagger UI for the fast API applications. So you see that intent is equal to code. Which version of Python are you asking? The second API generated response. This is the, as we saw that we need to return the response in JSON format only. This project requests me to response in JSON format only, so I have used like that. And let's see whether this stored in the route log JSON or file or not. Yes, just now we have used how to print in Python, and before that I have written can you. That's it. This application is completely dockerized, and you can check out this project at GitHub. The URL name is satyanagapravinkumar/LLM-Powered router for Indian classification. That's it for today. So today we have saw the practical demonstration of the LLM-Powered prompt router for intent classification. So how it is used in the real world AI apps too. And that's it. Thank you.